So in just a moment, we're going to take a look at the Eclipse developer tools. And before we get into that environment, let's stop here and pause and take a look at the software that we need to download and install onto our desktops first. So all this software is free. And the question is, where do we find it? So number one, we're going to start by downloading the latest version of the Java JDK. So there are two different versions of Java that we can download and install on our developer machine. The version that we're looking for, and more important than the version number, is the whether or not it's the developer kit or the runtime edition. So the runtime edition lives on just about every Windows desktop and every Mac desktop, but the developer kit is something that's special for developers because what it does is to include the build component so we can compile Java stuff on our desktop. So to find that, we can go to oracle.com. Remember that Java was invented by James Gosling at Sun Microsystems, and later Sun Microsystems was purchased by Oracle, so all the Java stuff is found at oracle.com. Now also, the extension to the Java language that we'll be focusing our attention to is the Android SDK libraries. So the Android SDK libraries are all the class files that extend the basic Java language to take advantage of all the native features of an Android phone or Android tablet. And we can pick this up at developer.android.com. So up to this point with the Java 7 JDK, the Java Developer Toolkit, and also the extension to that, the Android SDK, we could hypothetically or theoretically we could author the code using Notepad. We could use command line interfaces to compile and test the application, but that's really not the most efficient, and it's also not the easiest way to build the Android applications. What we want to do is to take a look at the Eclipse developer environment. So what we want to do is to download Eclipse, and remember that Eclipse is one of the top-rated development environments for building Java applications. And what we're going to do is to download this tool from eclipse.org. Remember that Eclipse was initially funded by IBM, so it's a widely recognized development environment. And we'll download this for free. And to make it even easier, Google has created this Android Developer Toolkit for Eclipse, which is basically a plugin. So this plugin that we'll take a look at in just a moment allows us to debug, to test, develop Android-specific project types within Eclipse, and we can find this at developer.android.com. So these are the four things that we want to download and install on our developer machine before we move on to build our first project. Now, one thing to keep in mind is that we can build Android applications on both the Microsoft Windows environment. We can use Microsoft Windows 7, Vista, or XP. We can also use the Mac environment as well. And as we go through the course, we can highlight the strengths of each of these different platforms. But as a general rule, they perform the same task. They're all capable of running the emulator, the virtual machine, to test out the applications on the desktop before we send them out into the real world, out into the Android market, and test it on our own phone. So let's start by taking a look at a sample application. And once we understand what the application does, we'll take a look at its code and also how to take a look at how to build an application from scratch. So first of all, when we look at the Eclipse development environment, we're going to take a look at the Android project template, and we can see the same pattern show up in all the applications. So we'll take a look at this hello world example, and we'll modify one of the string values slightly just so that we can see that the application that we modify is the same application that we're looking at. And these simple modifications are modifications that we apply to text files, XML config files, within the Android project within Eclipse. Okay, so we're looking at the Android virtual device here running on the Windows desktop. So we can run the virtual device on a Mac environment, we can run it on a Windows environment, and also we can specify and configure each of the virtual devices to have different screen layouts. So this is a sample phone. It's running Gingerbread 2.3. It's currently in the portrait mode, and also there's a toggle button that lets us flip back and forth between portrait and landscape mode, and we'll go through the course. We'll talk about how to write the UI code for each of the different layouts. So what we see here is the application name, Android Developer Toolkit, and a message that's displaying inside of a text view. And we'll take a look at the code and how this gets populated. So for example, there's an XML config file that sets this value, Android Developer Toolkit. It's the app variable name. And then this is a text view that by choice is choosing to pick up the content from a config file, but it could also have been hard-coded into the user interface code as well. So we'll take a look at that code and see how it works. So basically we have a phone, we have the keyboard and the control buttons that mimic what we would see on the hardware for this phone. And in this next step, we're going to take a look at the code that makes this work. So now that we understand what this example does, let's take a look at the code that makes it work. In the Eclipse development environment, we're going to take a look at the template structure for every Android project. And we'll also take a look at what are called run configurations, because once we have a single application, we want to be able to test it. And when we test it, a run configuration chooses which of the devices that we should test it with. Now, the Android project folders help us to organize the different components of the application. First of all, there's a folder called SRC, and it's lowercase. And this is where we find all of the Java source code. There's another folder at the root level of the project called the Generated Files folder, GEN. And basically, this is the code that's auto-generated by Eclipse. And it provides a bridge between the Java raw code and some of the markup languages that are employed by Android. So under the Resources folder, RES, we're going to find out that there are a number of different XML file formats that are used for different things like animations, the user interface, the string content. There are a number of different ways that the Android development environment makes building an application very rapid. So all the rapid development tools we're going to find under the Resources RES folder. Now, run configurations are critical when we think about building one Android app that runs on different devices. So the hardware is different. We're going to find out that there are different screen sizes. We're going to find out there are different choices for the hardware itself. For example, the SD card may have a different size. And the way that we manage all these different testing environments is by setting up what's called a run configuration. So a run configuration has a name. The configuration itself is mapped to one single project. And also, we choose the device that it plugs into. So there are a couple of different ways that the device is plugged in. There's both a auto mode and there's a manual mode. Now under manual mode, when we launch the application, we're prompted to pick which of the virtual devices at that moment that we're ready to test the application with. Under the auto mode, we can actually tie one specific device to the application, to the project, and it will always run, it will always target that one hardware. Okay, so we have this application. We have the Eclipse developer environment loaded in the background here. So let's minimize the virtual device and focus on the developer tools. So Android Developer Toolkit is the name of the project, and when we create a project from scratch, we'll take a look at the wizard that lets us specify this value. So within our projects, we have these key folders. We have SRC, Gen, and RES. So the source code folder contains all the Java code. And if we expand this just a little bit more, we can see the package name. And when we create this from scratch, we'll see how this gets specified. But the basic idea is that all Java packages are globally unique. And the way that we achieve this globally unique identifier is by utilizing the company website. So we could say in reverse order, the top level domain, com dot, company name dot, and then something that we create for the package name. Now inside the Java package, we can see the code that we write. So for example, here's an activity. And activities under Android development are basically forms under VB.NET. They just have a different set of properties and attributes. They have a different life cycle. So inside of this file, we could double click on the file and open it in the text editor, and we could see the content. So there's a package descriptor. There's the import statements of all the class libraries that this gets to utilize, and the definition of this class itself. So Android Developer Toolkit _ activity is extending the base class of activity, and it's doing something. And in this example, what it's doing is to load the content from an XML file. So r.layout.main, This is a file called main.xml that allows us to build a user interface in a language that looks a lot like HTML. It's basically an Android markup language, not a hypertext markup language. So the way that we find this, if we look in r.java under the generated folders, we can see this bridge, and this bridge basically bridges the gap between the Java code, the runtime environment, and the Java virtual machine. And the resources like the layout files, main.xml, these are config files or markup language files that describe the application in a higher level language. So in r.java, what we're looking for is a reference to something called the class r.layout.main. And we find that reference here. So here's main.layout under R. And the basic idea is that the Java runtime environment is going to be looking for a pointer, a handle, that's an integer value that tells it how to get a reference to objects that are built in the user interface. So in this example, let's take a look at the user interface object called main.xml. That's what gets loaded when the application starts. So when the onCreate event fires for this class, we're going to set the focus to this form called r.layout.main, which is actually this file here, main.xml. So inside of main.xml, we could take a look at the content for the layout of this page. So just like in HTML, we have a root node in XML. And we could space this visually to see that the text view node is a child under linear layout. And there's actually one tag above this tag. It's a frame layout. But just like in HTML, we have what's called a body tag that lives under the root node of HTML. In this example, we have a linear layout tag, which is replacing a body tag for the content. And it actually lives under one other hidden tag, which is the root element. But we don't need to know that right now. All we need to know right now is that we have a linear layout that contains content. And one of the behaviors that's unique to a linear layout is that we can specify the arrangement of each of the child objects as either being arranged vertically, so one on top of the other, or horizontally, so one right and left. We're just going to go across the screen. So the orientation is something that we can specify under linear layout. And basically a linear layout is like a table that either contains one row with many columns, or it contains one column with many rows. And we flip that with this attribute, this property called the orientation. So within the linear layout, we see this text view. And the text view has content that's coming from this property text. So when we program an application, there are three different ways that we can actually set a property like this one, this text property. We could A, programmatically set its property within Java. So we could say object name dot text is equal to something, or set text, and then pass in the parameter. Also, we could set a hard-coded value here. We could say something like hello world, just type in HELLOWORLD, and that's a raw string. But what's happening here is we're actually getting a pointer to a config file. So in a file called strings.xml, and we can see that here under values, if we open this up, we can see the resources for strings, and we see one called hello. And the way that this gets referenced at runtime is that the main.xml file here is referencing it by @string. So it's like a way to redirect the reference to this variable hello. So it's saying, look in the file called strings.xml and look for an XML node called hello. And we have that. And that's where this content is coming from. So we can actually change content here that would then show up in the application. And if we take a moment here, if we stop and look at the way that the output turned out, we could see the words 1, 2, 3 hello world, comma. And that's what's coming from this strings.xml node, this config file. Also, we could see the app name. So the app name parameter, Android Developer Toolkit, is what's being displayed here at the top of the screen. And we can see it other places as well. So for example, for the operating system, if we hold down the home key, we can see all the applications that are currently running. And the application that we're currently running is called the Android Developer Toolkit. And we can see that XML config file value actually showing up here as the app name. So we'd see this in the Android market, this value right here. So whatever we pick, it's going to show up everywhere. It's going to show up inside the phone itself. It'll show up on the Android market. things that don't show up everywhere are things like the Eclipse project name. So Android_developer_toolkit. This is a name that is used only within the context of the Eclipse developer environment. It never makes its way outside into any phone. It doesn't make its way out into the Android market either. So now let's take a look at what are called run configurations. So in the Eclipse developer environment, under the play button, there's a tab that allows us to jump into run configurations. Now what this does is to help the project know what to do when the build process occurs and we want to test this out. How do we test this? What device will it be tested on? So if we were building an iPhone application, for example, we know the iPhone is a specific hardware, and there really aren't a lot of questions about what size is the screen and so on. But under Android, every time we build an application, we actually have to test it under different hardware settings because there are so many different brands of phones that are running Android that we want to know what happens when we look at an application run on different resolutions. So in this example, we have one single run configuration for this project, and we can see here that the reference to a run configuration points to one and only one project. We could change projects, obviously. So we could see that Android_developer_toolkit is the project that this run configuration is set up for. Now the next question is, when we run or launch this project, what will it do? So if we go into the target, we can explain what to do with this project. We could either A, manually provide a list to the user or the developer at build time to deploy this onto a phone connected to the USB port or to one of the Android virtual devices that have been configured, and we can take a look at that in just a moment. Or we could say that every single time that we launch this project, it will always run on one specific platform. It might always run, for example, on an Acer tablet with the Honeycomb operating system. It might always run on a Zoom from Motorola. So what we can do here is to say either A, bind this to one particular platform, or B, every time have it manually ask the question to the developer, at this moment, which phone or which tablet should we test this on? So run configurations are the way that we map a project to a specific deployment type. So it's either A, a USB port connecting to our phone, or B, it's a virtual device. Now, when we talk about the different virtual devices, there's a toolbar button here that opens up this manager. So the Android SDK and AVD Manager is a tool that allows us to configure our virtual devices. And the basic idea here is that we're going to assign a friendly name to each of the devices that we work with. And we're going to look at the Android device 1, which has been configured as a Gingerbread 2.3.3 device. That's our primary platform. Also, we'll be taking a look at the Honeycomb platform as well, which is the tablet environment running Android 3.1. So these are the two different platforms that we're going to focus our effort on. And when we build these projects, there are a couple of different names or nomenclatures, vocabulary that we should be aware of. First of all, the API level is an integer. It's like a primary key in a Microsoft SQL Server database. It increments by 1 for each additional record in the list. But we also have this descriptor called platform. And the basic idea is that every platform, which is like a version number, correlates to one and only one API level. So as a developer, from a computer science mindset, we want to be able to uniquely identify each of these platforms. So we use an integer, and it increments sequentially. But for marketing purposes, we have these versions that are platform names, but there's a one-to-one relationship between them. So whenever we set up our project, we're going to do a couple of things. We're going to set the minimum API level, or the minimum version of the Android OS that we expect the user to have to run this application. And this is important because in the Android market, if a phone browses the Android market, say running the original Droid on the 1.6 platform, if the app requires a 2 or version 3 OS, that application is going to be hidden from all the phones that don't support that particular platform. So the API level that we specify in our new project wizard actually affects who can and cannot see our project within the Android market.